All right, welcome back. So in the previous lecture, we wrapped up the end scene hierarchy. We were able to jump through our 3 levels by either pressing the buttons or pressing the escape key when we were in level 1 to jump to jump to the end scene. So now, back over here at our instructions document with all of our settings and whatnot, we wrapped up the end scene hierarchy stuff down here towards the bottom, and we have our return to phase 5. So if we click on that and go back up to phase 5, this is just a verification, to double check that we have added our game manager prefab to every one of our scenes. And remember that the buttons link to the prefab asset, not the prefab instance, and that we've added all 3 of our scenes to the build settings, sorted them correctly so that everything flows logically, and there's no commit or apply button on that dialog. You just close it after you've updated your order and that kind of stuff. So this process of adding your scenes, remember that this basically applies to any new scenes that you add to your game as you're constructing. If you want it to be part of your game's flow, then it needs to be part of that build settings list. Okay, so now we can move on to our phase 6, where we're actually constructing the objects that let us play an actual game. So again, I've got these things over on my other screen, so I'm going to jump back to Unity and start creating these items. So back, just double check this, yes. So back over here in Unity, to construct the stuff for level 1, I need to be in level 1. So I'm going to go down here, double click to load into level 1. Now, here in the hierarchy, we're actually going to create a number of items. First of all, we're going to create the area that kind of borders our level. This will be our play area that keeps the ball inside what our camera can see. We'll also have a floor that will eventually become a death plane, lava. It'll trigger the lose condition. But for now, we're going to treat it just like the walls and the ceiling so that we can actually play test the game's mechanics without worrying about having to really play the game with any form of skill and not actually lose. We'll also create the ball so that we have something to bounce around in the scene. We'll create the paddle so that we can kind of line up the shot initially, but then also try to keep it from hitting the floor as lava. And then we'll also have a brick that will allow us to start scoring points. When we destroy all the bricks, we are racking up a score over here. We're decrementing the number of bricks that are still alive in the scene. And once we destroy them all, we win. If we hit the floor before that, we lose. And then we go over to end and we reflect that information through the scoring and through the UI that we were just talking about in the previous videos. So the document itself, the phase 6, also has a list of items down at the bottom. So we're going to build out the play area with its children, temporarily leaving the floor as a collider while we're testing, and before we submit, before we're all finished, we need to turn all the floors and all the levels that we've created into triggers. Otherwise, there's a spot on the rubric right over here, collisions and triggers. Make sure that all your floors are triggers, otherwise you don't get a certain amount of points for this item. Okay, so back over here, then we're going to create the paddle, ball, and brick, and so on. So if you click through this link, it'll take you down to the bottom where the various settings are. So if we click through to that, this is the listing that I'm going to be following as I construct these items in the scene. So if you need to double check what those values are that I'm talking about here, you can pause the video, take a look at these values, and go from there. Okay, so back over here in Unity, I know that all of my objects, my walls, are going to have a very similar magenta, obnoxious magenta, kind of like an error code. If I see that color, I know something's wrong. The paddle, the ball, the brick, they're all going to have different colors. Now, according to the Arkanoid layout, if you look, each one of these things has, this row has its own color, this row has its own color, and so on. If you decide later on that you want to make multiple bricks and have different colors, realize that since we're building for this demo one single brick, this green one right here in the center, that's what I'm going to build. If you want to create the purple or the magentas, the blues, and so on and so forth, a material is a shared resource. If you have a bunch of bricks and you have them pointing at one material, you change that one material, just like with the prefab asset concept, all of your instances get that modification applied to them. So you would need to create additional materials and then potentially even additional brick prefabs. Maybe name one green brick and the next one over red brick and magenta brick and so on. And each one would have its own unique material. Green material, blue material, red material, and so on. That way you can update them each individually. So just something to watch out for. Now, in the project window down here at the bottom, we have our materials folder. So we want to create several materials. So I'm going to right click on the materials folder, go up here to create, and about a third of the way down or a quarter of the way down we have material. Now I want to create, according to the document, I have 4 different materials. So what I'm going to do is, instead of renaming this first one, I'm going to just commit that name, right? Hit enter. And then duplicate this 3 times. Control D, Control D, Control D. I want to take one of those 4 and just rename it. The first item is going to be wall. And I'm going to change its color over here to be 255, 0, 255. Remember, the wall is going to be just outside the viewable space, and if it encroaches into our scene in any way, we know that something about our numbers, our math, our positioning math, our scaling math is wrong, and we need to just fix it. So the wall is currently set to magenta. Pick any one of the 3, rename. Next one will be paddle. And the paddle is actually going to use a similar color. Again, I color matched it according to what the paddle is in the Arkanoid layout. So if you enable that and take a look at it, it's going to be more of a kind of gray color. So its color is 145, 145, and 145. One of the other items, let's name it ball. And its color kind of has this little like blue tint to it. So we're going to use the values 118, 177, and 219. So it's like baby blue looking thing. And our final item is going to be named brick. Now again, if this was a green brick, a red brick, blue brick, magenta, whatever, you might want to rename this to reflect the actual color. But again, because this demo sticks with just one item, I'm just going to leave it as brick. I'll leave it up to you to create additional materials so that your additional brick prefabs can have their own unique colors. Remember, these are shared resources, so shared assets. So you'd have to slot in each color uniquely to the individual brick prefab that you were looking to color at that specific time. So the brick, we want to give it, I said we're going to deal with the green. So this is going to be 0, 0, 0, 255, 0. So again, it should be this lime green color. The values are 0, 255, 0, and I'm leaving the alpha channel at 255 as well. Okay. So baby blue ball, green brick, gray paddle, magenta wall. Those are the 4 color materials that we're dealing with. Now, in order to construct the play area, basically what I did was I took what the camera can see, I took the size of the Unity unit cubes that it creates when you create a 3D cube, and I did some math to basically reverse engineer how the spacing should be for both the walls and the ceiling and floor. So if you want more information on exactly what those values look like, that's this whole section right here, the math reasoning for it. And I'm going to go through and plug in these values as I construct these different objects. So to start out with, I need to create a game object that's going to be a parent container for all 4 of these walls. So left wall, right wall, ceiling, and floor. So over here in my hierarchy, let's create an empty game object. And remember, best practice, reset it. So hit the gear and hit reset. Now this game object we're going to rename to be play space area. And underneath this play area, I'm going to create my 4 walls that border this level. So let's go to the right click on the play area, create 3D object, and we're looking to create a cube. Now, I'm going to create 4 of these things, or more specifically, I'm going to duplicate 3 more of these things, but since I'm going to be customizing it, I can already, right here with this first one, I can prime it with a little bit of information. Or if I duplicated them, I could use Shift Select to select them all and multi-object edit, and drag whatever their items are. But in this case, since this is going to be one of the 4 edges, I'm going to come over here to where it says the material renderer and materials. And if I click that drop down, you'll notice it currently says a size of 1. If you just drag and drop this wall material onto the name materials, it'll increase. Let me just demonstrate. Don't do this, but I'm just going to demonstrate. If you drag and drop it onto the materials, it'll become 2. You'll retain the original, and you'll get your wall, and you'll get a warning saying that it can't really figure out this particular shader, doesn't work with that kind of stuff. So I want to go back to 1. And what I actually want to do is replace this default material with the wall material. So if we drag and drop the wall material right there onto the default material, the wall now becomes this color. Okay. And you might notice that it's kind of shaded out here. It's not as vibrant as you'd initially expect it to be. Well, if we take a look at our cam and light, remember the direction of the light is straight down the Z, so it should be illuminating 100% on this surface. But I also dropped its intensity. So if I crank it up, that you start seeing it kind of gets a bit brighter. But it turns out this is because we need to bake our lighting. Now, because I've made a modification here, just to demonstrate that effect, notice how the value 0.5 is actually bold compared to what it was a second ago. The word intensity is also bold, and there's this little blue line right here along the side. Because the directional light was part of this cam and light prefab, what I have done is effectively changed this instance value from what was inside the prefab asset down here at the bottom. I've now committed an override to this object that doesn't exist in the parent. If I go back down to the parent, to this asset, and change the same intensity, this 0.5 will stay because Unity sees it as an override. If you want to see what things you've made modifications to, if you go up to the parent and come over here to the overrides, you'll see Cam and Light has a directional light child, which has a light component, and there is something about it that's different. And if you click on it, you'll see the original, the source, which is kind of like the prefab asset down here, and then your modification. So in this case, I see that comparing all these things on the left to all these things on the right, this bold item and this blue line indicates that there's a change. Now, if I wanted to keep this change, I could click Apply to push that change back down into the parent if it was a different value. But in this case, since I've not made a significant change, I actually want to revert it. And if you had multiple changes, that's why you have Apply All over here. And in this case, I can revert that one change if I had multiple changes, or I can say revert all changes. So here I'm just going to click revert, which will undo that one change, and now the overrides say I have no changes inside the scene, inside the cam and light hierarchy. So now if I look at light, directional light, I see intensity has gone back to normal, the value's gone back to normal, and we no longer have that blue line. So that's the workflow of making changes here, committing them back down to the asset. It's also worth noting that when you change this stuff up here, you're changing something inside the scene. So you'd need to save the scene. But the item that's inside the scene is actually a reference to the item down here, to the asset. So if you change the asset, what gets referenced into the scene is not technically seen as a scene change. So you can change assets all day long without having to touch the scene. So just a neat little feature. If you've got a bunch of scenes, you can make modifications to the asset without making adjustments to every single individual scene. So just some neat little workflow thing to watch out for. So I'm going to save that scene. So in this case, I believe the issue here is not so much my intensity, but it's the lighting. So I mentioned earlier that I was going to show you guys how to fix your lighting, and the process, generally you want to do this like every single, towards the end of the project once you've got all your stuff in here, because the lighting will be partially baked as I continue building stuff in this scene. But the way you'd get to it is up here under Window. There's a, let's see, was it under, yeah, Rendering, Lighting Settings. This is a whole nother window. And what you want to do is under Scene, down here at the bottom, you see where it says Auto Generate and Generate Lighting. This may or may not be checked to auto generate, depending on what version of Unity you're using. Down here in the bottom, auto generate is turned off. You can manually either turn it on, and by the way, clicking that guy down there brings this window back up. So you can either click auto generate and it will trigger an automatic update, or if you need to, and by the way, this is going to update as I continue building more stuff in my scene, so maybe I don't necessarily want that, and if that's the case, maybe you go through and you turn it off, and then later on, you manually click Generate Lighting. Unity's going to go off, it's going to process all the settings, do all the lighting calculations, and then finish up. Now, you need to do this arguably towards the end of your project, right? Once you've got everything built, and you need to do this for every single scene. Yes, I know it sounds awful, but just going through and click, load up a scene, click this button, wait for it to finish, load up the next scene, click this button, wait for it to finish, and so on. Now, what happens when you do this is you'll be given, here inside your scenes folder, right alongside the scene you are working in, you'll be given another folder with the same name. Inside this folder is the lighting calculations that Unity has generated for your scene. So just realize that you're going to get this extra thing for free that contains all that information. So as you continue working, if you see this kind of stuff, just realize that it's in the spirit of keeping your lighting correct. So in this case, since if I continue building this level and I keep getting lighting issues, maybe I'll enable it. But keep in mind that when it's enabled, it's going to constantly try to do updates, so it might bog down your performance, right? You might suffer a performance hit while you're working in your scene, so you might want to keep it turned off by default. So the next step is, now that we've got our magenta in here, let's go ahead and duplicate this cube 3 times. So with it selected, Control D, D, and D. Now, we need to pick one of these items. So according to my list over here, the first item is called Ceiling. So let's rename the first cube to Ceiling. And the P.Y, or the PY is position Y, and the S and then X is scale X. So if you find, as you're looking through here, through the documentation, you're like, what is P and what is S? That's position and scale. It says it right up towards the top, just above the math reasoning. So we want to change the position of the ceiling in the Y, right? Py. We want to change that to 5.5. And in case you're curious, like, okay, well, I adjusted it here. Why don't I see it over here? Remember, I'm looking at the canvas. This thing is massive. So what's actually happening is way down here in the bottom corner. So what I want to do is, since I'm going to be working with the play area, I can select play area, or I can stay with this ceiling. And with my cursor over the scene view, just press F to frame selected. It's the same thing as edit frame selected. And we zoom in to the object. Now I'm going to zoom out. That's actually because I'm dealing with a multi-monitor setup with some special software. So I'm going to zoom out and kind of move the scene around so I see what's going on. But now you'll notice that at 5.5, it puts the cube just above our play area. If I pull it down by just the tiniest little amount, see how I see it bleeding into my level? That's the indication that something's wrong with my numbers. So I'm going to undo that change. And now, since I raised it up in the Y, I need to scale it horizontally, which is the scale X. So the SX value is 9.75. And this will cause it to overlap the edges of our camera's area by just a little bit. And so the left wall and the right wall will overlap this by just a little bit. That overlap is going to help us keep the ball inside our play area. Okay? So the next item, the next cube 1 over here, that's going to be our floor. So, and I'm naming these with capital letters, F, C, that kind of stuff, because the code later on will write to monitor for the floor uses a capital F in its string, in its string comparison. So if you change this to something like floor with a lowercase f or bottom or whatever, you'll want to make sure that the code is also updated, otherwise you'll have a problem. So the floor needs to go down by 5.5. So let's do negative 5.5 in the Y. And it also needs to scale horizontally. So scale X, SX, it needs to be 9.75, just like the ceiling. Now, as the documentation notes, we are going to leave the floor as a collider for now. We'll come back to it later on and turn it into a trigger because we're going to want the ball to fly through it, which if it's a collider, it's going to bounce off. If it's a trigger, it'll fly through it. We're going to call two different pieces of code to manage those systems, which this also reminds me, I forgot to put the colliders on our objects, which actually, no, sorry, rewind. The collider's already here. It's part of Unity when it creates the objects. Little memory lapse there. So in the future, we will come back to the floor, to the isTrigger property right here, and we will enable this, but in the future. Now again, because we're going to turn the play area into a prefab, later on, if all your levels have a play area prefab instance, all you'll need to do is update the prefab asset down here. Go into the prefab, check that box, and then every one of your levels will automatically get that setting set without having to change every single level. So just something to watch out for. Okay, so the next cube, we're going to name it left space wall, and it needs to translate in the X, so position X, by negative 4.875. If you accidentally use something like 0.785, or you mix this number up, 4.875, negative 4.875, then your cube will either be way off to the left or encroach into your play area, which means you should double check your values. So negative 4.875 for the left wall in the position X. Now the position Y, we need to scale it vertically, and the value here is going to be 11. See the overlap right there on the top and right there on the bottom. Okay. Scale Y, value of 11. Now the last cube, we're going to rename that to right space wall. and its position in the X, we want to go to the right, which is positive, so it's going to be 4.875. And it's also going to be scaled in the Y by 11. Now we want to take this play area and turn it into a prefab. So drag and drop it onto the prefabs folder. And while we're at it, we can save this scene. The next item that we want to work with is going to be the paddle. So we're going to right click, 3D object, cube, and rename it to paddle. Now, for starters, I want to reset its position. So use the gear and say reset. And I'm going to pull it down in the Y. So it's PY, position Y. We want to go negative 4.205. Negative 4.205. Now we want to scale it in the X, so the SX value is going to be 1.2. Its scale Y, SY, is going to be 0.25. Now, just like what we dealt with the walls material or the play areas, children, their materials, we also have a paddle material. So this element 0, let's go ahead and replace default hyphen material with the paddle material. So drag and drop, and now the paddle goes to this kind of gray color. Now the paddle is going to be governed by physics, just like the ball. And in order to properly talk to the physics engine, we need to add a rigid body. That's what gives it functionality. Now, in order to do that, down here under Add Component, I want to click Add Component, clear out whatever the search was, and I can search for RI to start narrowing down to rigid body, or it's actually listed right here under Physics. Again, this is the 3D physics, not to be confused with physics 2D. That's a different subsystem. So physics, and then if you go looking through this list down here towards the bottom, but again, the easiest, quickest way is to just type in RI and it bubbles to the top. So the rigid body, we're going to customize this thing 100% through code, which, since we're going to work with it through code, we need a script. So down here at the bottom, Add Component, and we're going to start typing paddle. And Unity should automatically select this new script, but for whatever reason it's not. So let's just manually click on New Script. And we're creating a new script named paddle. So create and add. So when Unity finishes compiling, we can come over here and grab the paddle script, which was placed at the bottom of our assets. This is why we have it in one column layout, so we can see all these things. And we want to put that script inside our scripts folder to make sure that, again, we're staying organized. And that's going to trigger a recompile when you do move scripts around. And now we want to take the paddle and turn it into a prefab. So click and drag paddle down to the prefabs folder. And let's go ahead and save that scene. Now the next item that we're going to build is the ball. So if we, here inside the hierarchy, right click, 3D object, and we're going to create a sphere. So rename the sphere to be ball. We're going to reset its position, so hit the gear and hit reset. And the ball is actually not going to be positioned anywhere specifically. We're going to leave it sitting at origin because we're going to write code inside the paddle that will find the ball and basically put the ball right above the paddle and cause it to follow along as we translate the paddle back and forth. So it will be mapped as long as we're not yet playing the game. Once we press the space bar, that will fire the ball, and the ball will be under its own control via physics. So we're not worried about its position, so just leave it where it is. We do, however, want to change its scale because this thing is massive. Now, in the document, it says to change the scale uniformly. That means all three components, X, Y, and Z. We're going to demonstrate. I'm going to come over here to my scene view, disable 2D, and kind of allow myself to see the ball from kind of an oblique angle here. And watch what happens. As I start to change, and you should be doing this too, change your ball, its scale. We're going to change it to 0.2. in all three axes. But as you start typing, watch. 0.2. Notice how it flattens, but then there's this green set of circles around it. Okay, let's change the Y. 0.2. Now it's like this elongated pill kind of thing, but then the two green circles are still there. Those green circles are the collider down here, the sphere collider. And it scales to the largest possible item. So the idea here is that you want to scale all three axes at the same or to the same value. Otherwise, your collider is going to be so large that as this tiny little ball hits one of the edges, it's going to actually hit more into the level. It's going to look completely wrong. So as soon as we change the as soon as we change the Z to match the X and Y values, we will now see the collider sphere, those two green circles, match the same size as the ball. So now we don't get any kind of weird physics out of this thing as it goes bouncing around the level. So now I'm going to go back to 2D mode and basically, let's see here, deselect my stuff and select because I want to pull back in the scene, I'll go ahead and pick the play area and press F while my cursor's over here, and it pulls back to the outer edges, and now I can kind of zoom back in. So when you set the scale to be uniform, we get a good collision value. So now we also are going to control the ball using physics. So we want to add component, and if we start typing in RI, we get our rigid body, so let's add that component. And then also, we need a script to control it. So we need a script called ball, and it would normally select this new script, but for some reason it's not. So let's click new script and click create and add. So Unity is going to compile, and I'm going to, when it gives me control back, I'm going to pull this up a little bit so we can start seeing our content. Now I want to take that ball script, drag and drop it into the scripts folder, and take the ball, and actually I'm missing one thing. I'm missing its material. So right here with the default hyphen material, let's replace that with the ball material. So we get that baby blue going on there. Now take the ball from your hierarchy and turn it into a prefab. Drag and drop it onto the prefab folder and save this scene. Now the final piece to be able to actually build this thing out, the final thing that gives us scoring information and something to actually destroy, is our brick. And if you wanted to create multiple bricks, you would potentially create multiple items here, multiple prefabs, and customize them. You can also create the prefab and duplicate it. So if I, for example, if I took this ball, duplicated it, then I could customize the first item, the second item, third item, fourth item, and so on, changing their material over here, right? I could create multiple materials, and I could change all the different aspects of each of the items, whatever it happens to be. Brick, ball, paddle. But in this case, our game is only going to have one ball, one paddle, and one brick. You can create multiples should you want to. So here inside your hierarchy, let's right-click And a brick is going to be a cube, so 3D object cube. We can rename it to be brick. Because of the repositioning earlier, it automatically reset itself to 0, but if it didn't, go ahead and hit the gear and say reset. This brick, the idea is I'm going to try to line it up with that center green brick from the Arkanoid layout image earlier. So in order to do that, I want to change its position. Now this is going to get a little detailed in terms of its accuracy, and you can get close to this. It's a little subjective, but I'm going to try to stick as close to that image as I can. So the position X, I'm going to set that equal to negative 0.021. The Y is going to be set to 1.111. Its scale in the X, we're going to change that to 0.58. And its scale in the Y is going to be 0.27. Now, the material is going to be swapped out for the brick material. We're not going to use any kind of physics on this, otherwise the ball might, or the brick might fall or bounce around the area. We don't want that kind of behavior. So but we do actually have some scoring and some hit detection calculations that are going to be in unique to every brick, and we're also going to have the ability for all the bricks to kind of share a common count, again using a static to share all the individual brick instances at the brick class level. So in order to get all that functionality, we need a brick script. So add component and type brick. And since it already selected it, I'll hit enter. We go on to the next option and enter one more time to create an add. Now, it is also worth noting that when you create multiple bricks, you can create multiple prefab instances, multiple prefab assets, but you only need to create one prefab type. This class, you only ever need to create one of them. All your functionality is shared across all of your bricks. So there's no need to create multiple brick scripts. It's one single type, and it can be customized across all of your instances. So now that we have our brick script, let's go ahead and drag and drop it into the scripts folder. Again, keep ourselves organized. And let's verify that we got all our stuff on the brick correct. So our position, our material, and our script. So now let's take that brick, drag and drop it to turn it into a prefab. And just so we can verify the positioning, I'm going to pick the Arkanoid layout and enable it. And notice the brick is right there. It's that green brick kind of slid right into position. So turn it off, turn it on, and turn it off, because now we're not going to use that image pretty much anymore going forward. So now you can go ahead and save your scene. And at this point, we can verify with our document that we have indeed, we've checked the layout, we looked at it temporarily to see that everything does match up. We can see that all of our items have all their correct bits of information, and we can click the link down there at the bottom to return to phase 6. So click that, jump back up to phase 6, and we just verify that we indeed have everything all set up. So we have our play area, all the children, they have their settings, their position and scale, their material, and we turned it into a prefab. We are currently leaving the floor as a collider. We will come back later to change it to a trigger for completion and submission. We have the paddle. It has all of its settings. It has its material, the rigid body, the script, and we turned it into a prefab. We have the ball with all of its custom settings, material, the rigid body, the script, and its prefab, and it's been turned into a prefab. The brick has its settings, its material, script, and turned into a prefab. Note, the brick does not have a rigid body, nor does the play area or any of the children. It's only the things that we're going to govern with physics, which are the ball and paddle, just those two. So with that, I'm going to end phase 6 because the next phase is us actually jumping into the gameplay code. So we will jump into what is essentially all the code in these 3 images that go to build up all the actual functionality. So as I'm writing the code and testing it, making sure that everything is correct as the next few videos roll through, if you're running into issues, errors, that kind of stuff, remember, you can always pause the video, double check with the code here. But this is the final version, right? So there are some things like the to-dos we talked about. We'll be going through and writing some code that won't exist in the final version because we'll clean some stuff up. But then as I'm writing this stuff, you should be writing it right along with me, watching very carefully, listening very carefully to the individual keys and the individual glyphs, the characters that I'm writing in the code, and just double checking that your stuff is right on par with mine. Okay, so with that, I'm going to end this video and we'll jump into phase 7, the actual code, which will be broken out probably into the individual items. A video for the ball, a video for the paddle, for the brick, and then to wrap it all up with the gameplay manager and so on. So with that, next video, phase 7, we'll see you there.